the critical level. See, in my formula, I am using the Z star, and that Z star is called as the critical value. So just a different notation that I'm using, but still it is signifying your Z score number curve. All right. So here I am going to get inverse now 0.05, and that number is negative 1.645. You can plug it into your TI, plug it in. Second was option number 3, inverse now 0.05, and make sure you got the z-score value as a negative 1.645. That's right. So now on the right side of the density function, again you have 0.05. So that's going to give you the cutoff point for my positive z star, which is the mirror image, and it is going to be positive 0.1645. That is right. So the center is going to be right in the middle, and that's going to be your x bar. On either side from the center, I have an equidistant number. That equidistant number is what I call it as the margin of error. So that number is 1.645 standard deviations above the center, and that's going to give me the cutoff point, which is the upper limit. And the same way, 1.645 standard deviations below the center, and that's going to give me the cutoff point, which is going to be my lower limit. So what is the cutoff point there? The cutoff point is going to be called as the lower limit, and it is given by 1.645 standard deviations below the center, and take away that number from x bar. And the same way, the upper limit is from the center, so x bar plus 1.645 standard deviations above the center, and that cutoff point is what I call it as the upper limit. So my formula is the 90% confidence limits for mu is given by the sample mean plus or minus margin of error, which is going to be on either side from the center. So x bar plus or minus 1.645 times sigma over square root of n. So this is the formula that's going to be used for calculating the confidence limits for mu with a 90% confidence level. The same way, if I increase my confidence level to 95%, so when I increase my C level to 95%, the middle 95%, this we already talked about in chapter 13, I showed it to you. So with 68, 95, 99.7 rule, the middle 95% is going to have the number plus or minus 2. But if I'm going to be using my normal CDF, or if I'm going to be using my Z table, I am going to have the cutoff point for the bottom 2.5%, because I'm talking about the middle 95%. I'm left with the 5%, and that's going to be divided to both ends, and the probability is about 2.5. So inverse norm second was option number 3, inverse norm 0.025. That number is a negative 1.96, and the mirror image is going to be positive 1.96. So what is the meaning? From the center, you are going to get the cutoff point. That cutoff point is 1.96 standard deviations above the center, and that is given by x bar plus 1.96 sigma over square root of n. And the same way, the bottom cutoff point is going to be my lower limit. From the center, 1.96 standard deviations below the center. So that is going to give me another cutoff point, and that's called as the lower limit. So I have clearly explained all the terminology that I'm introducing, lot of new words in chapter 14. So just get comfortable with that, okay? All right. So what is the margin of error? So the margin of error is the equidistant number from the center. So 1.96 sigma over square root of n is the positive margin of error. Negative 1.96 sigma over square root of n is the negative margin of error. So what is the formula now? the formula is the 95% confidence limits for mu is still same as the sample mean plus or minus margin of error, and the margin of error will have the critical value for 95%, which is plus or minus 1.96, right? So this is what I mean to say. The meaning of your formula is the lower limit less than mu less than the upper limit. How confident you are? You are about 95% confident. All right. So you are finding the probable limits for mu based on the sample data. So based on the sample data, you are going to do the projection for the entire population, and you are finding the lower limit and the upper limit with the desired confidence level. So only change is as the confidence level is changing, your critical value is also going to be changed. The next one is again, if I increase my confidence level to 99 percentage. So the first example I have shown you when I decide to have my confidence level as a 90 percentage, I got the critical value as plus or minus 1.645, and the formula is x bar plus or minus 1.645 times sigma over square root of n. So what is the meaning? The meaning is the probability that it is going to be x bar minus 1.645 sigma over square root of m less than mu less than x bar the upper limit 1.645 sigma over square root of n, which is going to be equal to 0.90. That is right. So this is the meaning of your formula. Suppose if I increase my C level to 95 percentage, then I'm going to be using inverse now 0.025, and that's going to give me the cutoff value as plus or minus 1.96. So this is the formula. Again, I wanted to understand what is the margin of error. The margin of error is some number that's going to be on either side from the center, which is the equidistant number from the center. Okay, the margin of error is going to be the same number that is, the plus or minus number from the center. If it is a 99 percentage, suppose my C level is a 99 percentage, then my cutoff points are going to be respectively plus or minus 2.576. Okay, so with my Z star value, yes, I'm getting the lower limit and I'm getting the upper limit. So here I'm going to be using inverse now 0.05, because with the 99 percentage, you are left with only 1 percentage. That 1 percentage is going to be divided on both ends. So inverse now 0.005. So inverse now 0.005, using my technology, I get my Z star value as plus or minus 2.576. All right. So margin of error is going to be 2.576 standard deviations above the center, and margin of error could be 2.576 standard deviations below the center. All right. If it is below the center, obviously I'm going to have negative sign. If it is above the center, it's going to be with a positive sign. All right. So I have my formula. So what is the meaning? The meaning is I am finding the lower limit and the upper limit for mu. So you can call that as the population mean, or you can also call that as the true mean. Population mean or the true mean. Both are one and the same. The population mean. Okay. So this is the concept in your confidence limits. One more time, I'll just recap everything and then I'll take your question and then we will move on to the class worksheet. Okay. So that's right. So here you are going to have the confidence interval is the range of values. What is the range of values? The range of value is the lower boundary and the upper boundary. It's going to give you the range of values with associated probability, and that's what I call it as the confidence level. the associated probability or the level of confidence, they are all one the same. And this one is, how did you get that? You are going to take as many samples as possible from the population. So the population is going to have the unknown mean mu. The population, you do not have any idea about the mean. So you are going to take as many samples as possible from the population, but every single sample that you are picking from the population are going to have the same size. So here in your slide, you are seeing the samples that you picked from the population are same as 217. And now you see every single sample is going to have a different sample mean. The first sample gave you the sample mean as 132.5. This is only an example, okay? Don't worry about the numbers, okay? Don't worry about the sample observation. So just look at the numbers. So the first sample has the sample mean as 132.5. The second sample has given you the number, the sample mean as 134.2 and so forth. And what is the margin of error? The margin of error is some number on either side from the center that will give you the confidence limits for you. So suppose if you have your C level as a 95%, what you are going to see is 95% of your population will capture the true mean. Only 5% of the time it will miss that. So that's what you are going to get your lower limit and the upper limit. So that's going to be the slide that I am going to be showing here. Hang in there. Okay, here it is. That's right. So if you assume your C level as a 95%, you are going to be having the middle 95%, that means the 95% of the observations will capture the true mean. Only 5% of the time it will miss the true mean. So that is going to be because of the presence of the low and the high outliers in your data. 95% of the time it will capture the true mean. So let's see. Okay. So if it is your 68, 95, 99.7 rule, then you will have plus or minus twice sigma over square root of n. And if for the same 95%, if you are going to be using your inverse norm, or if you are using your Z table, the numbers are going to be plus or minus 1.96. So the approximation tells you the Z star value as 2, but the exact value is going to be 1.96. Okay? All right. So let me, yes, so here it is. So what are the components of your confidence interval? The confidence interval is written as center, or you can call that as a point estimate, plus or minus, the second component is the margin of error on either side. So if it is MOE or M, so M is what we call it as the margin of error. So this is going to be the center. From the center on either side, you will have positive margin of error, and this is going to be the negative margin of error. If M is going to be called as the margin of error. Okay. And what is the another component? The another component is probability, which is going to be called as C level, and that's always going to be in percentage. So the C level is always going to be in percentage. That is nothing but the area. You can say that as area, or you can also call that as the probability. Probability is the same as area. Right? That's right. So that is how you have the formula. So here I'm going to make a tiny table called as the critical value table. What is the critical value table? So when you maximize the C level, say 90% or 95% or 99%, the respective critical values are displayed in your table. the Z star value is what I call it as the critical value, and that number is plus or minus 1.645, plus or minus 1.96, and plus or minus 2.576. So you can tag it in using your TI and make sure you get that. So go to second was option number 3. Go to second was option number 3, inverse norm 0.05. Area to the left is negative 1.645. Area to the right is going to be, on the right side, is positive 1.645. So this is going to be my table of critical values. So the minimum I can think about is 80% confidence. Even that one is not good. It's pretty weak number for confidence level. So we always go with 90 or 95 or 99. So those are all the usual numbers that we use. We never go below 90%. But still, in some scenario, if you are not pretty confident about what we are doing, or if you are not sure about the confidence level, you can go for 80%, not below that. Okay. So for 80%, you are left with 20%, and that's going to be divided on both ends. So that will be 0.10 or 10%, and that number is going to be plus or minus 1.28. You can plug it into your TI. Try second was option number 3, inverse norm 0.10. So you get the critical value. All right. So the same critical values are given in your PowerPoint slide. That's right. So this is called the critical value table. Critical value table. Or the table of critical values. Okay. So these are all the preset numbers, and it's not going to be changing as long as the C level is a 90%, 95%, and so forth. Okay. So if you want, you can also add plus or minus before that, because that tells you the equidistant numbers on either side. Okay. All right. Any questions before I move on to the worksheet? Anybody has any question?
I'm looking at your critical value table right here, and for the 99% and then the 80% confidence level, is it the same of X bar plus or minus the value that goes with the 99% or the 80% value, and then times like the standard error? Because I see under the 99 and 80 that it's C star equals and not like a different notation like than the 90 and 95. Than how you route it.
So you are looking at this table?
Oh, I was looking at the one that you.
Oh, that what I wrote. Okay.
Yeah.
Okay, I'm going back there. Is this the one you're talking about?
Yeah, I just see under the 99 and 80 that it's Z star equals and then plus or minus the value, but then 90 and 8 and 95, it's like a slightly different, like that we don't have like that Z star in front of it. So I'm just making sure that it's just the same notation and that it's not different.
It's the same notation.
Okay, awesome. Thank you.
Same notation, yeah.
Thank you.
Good. All right. So you don't have to memorize this one. Usually this table will be given, or you can also make it in your formula card, whatever card that you are going to be making, okay? But this is the reason behind getting those numbers. It is inverse norm 0.05 with the 90%, inverse norm 0.025 with the 95%, and inverse norm 0.005 with the 99%. And if I'm going to be using my 80%, that's the least number that I can think about. I don't want to go below 80%. That doesn't show a good confidence level. So if my C level happens to be 80%, then this is going to be about 10%, which is the bottom 10%, because I'm left with the 20%, right? 20%. So this is going to be the top 10%. So this is the top 10%. So I'm going to be using inverse norm area to the left. So option number 3, second was option number 3. I'm writing here. Second was option number 3. And then inverse norm area to the left, which is 10 percentage. And that's going to give me the cutoff point, which is going to be negative Z star, which is negative 1.22. And the mirror image here is the cutoff point, and that's going to be Z star, the critical value, which is positive 1.28. So this is going to be your lower limit, and this is going to be the upper limit, as I say. What is the center? The center is right in the middle. The center is going to be your X bar value. That's going to be right in the middle, okay? And then on either side of the center, you will have the margin of error. So this is the margin of error, and that's going to be 1.28 standard deviations above the center, and that's going to give me the cutoff point. That's what I call it as the upper limit. So the upper limit is X bar plus 1.28 sigma over square root of n, all right? 1.28 standard deviations above the center is my cutoff point. And the same way here, it is going to be the margin of error is going to be negative 1.28 sigma over square root of n, which means there is a cutoff point. That's what I call it as the lower limit, and that is 1.28 standard deviations below the center. So it is X bar minus 1.28 sigma over square root of n. Alright, so here my goal is finding the probable limits, which is X bar minus 1.28. So based on your confidence level, you will be seeing your Z star or the critical values are going to be changing. That's it. So it's going to be very easy, and everything, all the questions are going to be answered based on your data. What are the numbers that you need to look in your problem? So you are going to be given the sample mean is coming. Yes. So what are the given information in the problem? So you will see the sample mean. Based on the single sample data, you are going to do the projection for the entire population. So you will see the sample mean. You will also see the population standard deviation. The C level, the probability level will be given in the problem. So once you are given the probability level, you can get the C star value, and then the sample size is very important. That is also going to be given in your problem. So basically, you will be given all these components, and then check, plug it into your formula, and then you get the lower limit and the upper limit. Easy. All right, so let's see the worksheet. So this